Here we're asked to graph this linear inequality with two variables. Step number one is to graph the boundary. Okay, so we're going to graph y equals 1/5 x minus 5. Now it's in slope-intercept form, so just by looking at it here, we know the slope is 1/5. Okay, and the y-intercept occurs when x is 0, so x comma -5. Let's go ahead and graph this up. Here I've drawn the blank Cartesian coordinate system, and we're going to start with the y-intercept here at 0, comma -5. From there we'll rise 1 and run 5, and that'll give us a second point on the graph. Now we can connect those up, but let me show you a quick trick. If I multiply numerator and denominator here for the slope, I can get the equivalent slope 5/25. So that means I can also rise 5 and run 25 and get another point on the graph. I did that to get the x-intercept here. Okay, so now we're ready to graph the boundary. Notice here the equal sign is inclusive, so the boundary, I'm going to draw it in with a solid line like that. Okay, the boundary is actually included. So for step number 2, we want to figure out what points solve this inequality. So we're going to choose a test value, and since it looks like the origin is going to be the easiest one here, I'm going to choose to test 0, 0. Let's see if it solves the original inequality. Okay, so the question is 0 greater than 1/5 times 0 minus 5? Well, certainly 0 is greater than -5, so it works. Now, what does that tell me? Basically, that tells me since 0 is in the solution set, that tells me anything in this region above the line should actually solve the original. Well, let's try it. Let's try 5, comma 2. 5, 2 looks like it appears to be in the solution set. Well, let's see if it works. Okay, is 2 greater than or equal to 1/5 times 5 minus 5? Well, yeah, it is, right? 2 is greater than 1 minus 5, which is -4. Any number in this shaded region, any ordered pair, that is, in this shaded region, should solve the original inequality.